Hi, in this presentation, I'm going to go over how to describe a graph and the key features you should be looking for. All right, so one thing you want to look for a graph is the line of symmetry. A line of symmetry is one you can reflect over. So for example, no matter what the graph looks like, if you can have a line that separates and if you folded the graph, the left and right side would overlap. So you want to look for a line of symmetry. Not all graphs have line of symmetries. The next thing you'd want to look at to see if the graph opens up or down. So in this case, if the graph opens upwards, you can basically hold a glass of water. You can also call this a happy face. Graph opening down is like a sad face. The next thing you want to look at for a graph is whether it's increasing or decreasing. We always look at graphs and read them from left to right. So as you look at a graph from left to right, you basically can trace over it and you can see if it's going up, it means it's increasing. If you're going left to right and it's going down, it is decreasing. You also want to look for x and y intercepts. So in this case, this is a line, but you want to look to see where the graph crosses either the x-axis as here or the y-axis. When you have an x-intercept, it means your y equals 0. When you have a y-intercept, it means your x equals to 0. All right, the next thing you want to look at for a graph is the domain and the range. So the domain, as I mentioned before in other videos, is the set of all inputs, and the range is the set of all outputs. For the domain, you always want to look across left to right along the x-axis, and for the range, you want to look up and down along the y-axis. What you also want to look for is endpoints on a graph. Now, not all functions have endpoints. Some go on forever, either to the right, to the left, up, or down. So you always want to make notice to see where there are endpoints. So for example, I can see I have an endpoint up here, and the description would be 1, 2, 3, 4. So -4 and 3. So if I could write an ordered pair, this would be an endpoint at the point -4, 3. And then I have an endpoint on the right, you can see on the bottom here. Next thing for graphs, what you want to look at is whether they have a maximum or minimum. So the maximum point is the highest point on the graph, and the minimum is the lowest point on the graph. And again, not all graphs will have a maximum or minimum. Some will continuously go forever upwards or forever downwards. The next thing we're looking at is continuous or discrete. So a graph is continuous if you can basically draw and not have to lift up your pencil. So all these graphs on the right are continuous. You could see that there are no gaps in the graph, whereas on the left right here, it is considered discrete because the points are disconnected. And the last thing you want to do when you're looking at a graph is to notice whether it is a function or not a function. The easiest way you can tell if a graph is a function is by using the vertical line test, and that is a visual graph. So if you're looking at any graph, if you draw a vertical line anywhere on the graph, it should only cross at one location. If it crosses only at one location, then it is a function. So you can see that the leftist graph here, the graph on the left, is definitely a function. The graph in the middle is a function because using the vertical line test, which is my red vertical line, it only crosses the graph at one location. Whereas the last one here is not a function because it fails a vertical line test, which means if I draw a vertical line, you could see it crosses at 1, 2, 3 spots. So this makes it not a function.